Here in question 12, we have some questions on graphing trigonometric functions. They ask us to draw the graphs of tan x plus 1 and cosine of 2x in the domain of negative 180 degrees to 180 degrees on the same system of axes. What I like to do when drawing these types of graphs is I like to just draw the basic graph of whatever it is, tan or cosine or sine, whichever ratio they give me, and then adapt it to the extra numbers that they put in there. So let's see tan x. What does the basic graph of tan x look like? If we have y equals tan x, we know that it has a tan of 90 degrees doesn't exist, so it's got an asymptote there. Same at 270 degrees. Add negative 90 and at negative 270. What I'd like to do is just plot a couple of the critical points to see where that leaves us. So we'll go with 0 degrees to start with. Tan of 0 is 0. Tan of 45 degrees is 1. Tan of 90 doesn't exist. Again, tan of 135, negative 1. Tan 180 is 0. Tan 225 is 1 again. And tan of 315, I think it is negative 1. Okay, so what it would look like on the positive side here, it's just like that. Okay. But now, what is tan x plus 1? Okay, well, let's have a look at these values over here. This is the full format of any type of trigonometric function they can give you. If they give you y equals a sine of b brackets x plus b plus q, what do those a, b, q, p, and q values mean? The a value here is called your amplitude, and that is calculated by saying the maximum value minus the minimum value of the function divided by 2. That's your amplitude. Okay, and how that relates to how to change the look of your graph is just you multiply each y value by that a value. By a. That gives you a new coordinate on here. I guess if it were y equals 2 tan x, we would have said the y value here is 0 times 2 remains 0. 1 times 2 would have gone shifted to 2. Negative 1 times 2 would have shifted to negative 2, etc. Okay, the b value here, that tells you the number of full cycles per its original period. Okay, so b is the number of cycles per original period. Okay, so now the original period of a sine and a cosine function is 360 degrees, and for tan it's 180 degrees. Remember that not all of them are the same. Now how does this relate to shifting the points or to altering the points there? Well, we'll take this relates to the periods, that's related to the x-axis values, the x values. So now, let's say for this tan function, okay, tan, we've got a point here 0, 0, and now we want to see what happens when we have, say for instance, tan of 2x. Okay, so that means the b value is 2 repetitions per 180 degrees now. So we have to divide each x value by the b to get our new x coordinates. So this coordinate here was 0, divided by 2 remains 0. Over here our x coordinate was 45, so we'll have to divide that by 2 to get 22.5. And the same here, this value here is 0 on the y-axis but 180 on the x, divided by 2 gives us 90. Same with the asymptote. Okay, asymptote was at 90, now it'll be at 45. So what you do here is, that's x looks like an x. Let's just call this multiply. Now here we want to say divide each x value by b. Okay, negative p. So that is just the opposite sign of whatever is added to the x in the brackets there. So that is your horizontal shift. Okay, horizontal shift That just means if we had tan of, in brackets, x plus 50, we'd move every point 50 to the left on the x-axis. Okay, so all we do is shift to the right or left. Here the right will be if it's a negative sign, and the left will be if it's a positive sign on the x-axis. And for Q, that is our vertical shift, and that is just shifting up or down by the value Q, but this time we're not looking for the opposite sign, it's just what it is. So here we'll just shift up or down, up if it's a plus, or down if it's a negative on the y value. Okay, so that's what we're going to try and do now. So we have here tan x plus 1. Okay, so here we had our our initial tan values was at, let me do it on this graph here, it doesn't look so confusing. Tan of 0 would usually be 0. Okay, and now we'll add 1 to it because of that plus 1. So there will be one of our points. Tan of 45 is usually 1, but we'll add 1, so it'll become 2. Tan of 90 doesn't exist, that's an asymptote. So we'll draw that in here. Okay. Tan of 135 is usually negative 1. So now it'll become negative 1 plus 1 will be 0. And tan of 180 is usually 0, but we'll add 1 and it'll become 1. Okay, on this side we'll have our asymptote at negative 90. And again, tan of negative 45 would usually be negative 1, so we'll move it up to 0. Tan of negative 90 doesn't exist. Tan of negative 135 would usually be 1, we'll move it up to 2. And tan negative 180 would usually be 0, we'll move it up to 1. Okay, now we just draw the graph. Okay, so this one goes up like that. And tan is always an increasing function, as we always read graphs from left to right. Yeah, it doesn't have to be pretty. And over here, that's it. That is tan of x plus 1. Let's just call this f. Okay, now let's look at cosine of 2x. Cosine of 2x, we saw here that would be the b value, sine of bx, or cosine of 2x. That's the number of cycles per original period. So this means we've got a cosine that has 2 cycles for every 360 degrees. So its new period is 180 degrees. And what we said here is we want to divide each x value by b from the original. Our original cosine graph would have 0 and 1 as a value here. So 0 divided by 2 stays 0. And cosine of 90 would usually be 0. But now we have to divide our x value by 2. So 90 divided by 2 gives you 45. Okay. Now cosine of 180 would usually give you negative 1. 180 divided by 2 is 90. So at 90 we'll have our negative 1. Then cosine of 270 would usually give you 0. 270 divided by 2, 135. And lastly 360. Cosine of 360 is equal to 1. We'll divide that by 360 by 2 to give us 180 and 1. Okay, so here's your positive side of your cosine of 2x, and the negative side will just be a mirror image of it. Okay, and there you go. We'll call this one g of x. So that's done. Now let's look at what else they ask us. Write down the period of g. Okay, well we said our b value, which in this case was 2, because we had cosine of 2x. So that tells us a number of cycles per original period. So now we've got 2 cycles per 360 degrees. So how many degrees for 1 cycle? Well, divide by 2, so we'll get 1 cycle per 180 degrees. So that is now our period. Okay, so you can just simplify that to say as your period equals your original period divided by your b value, which in this case was 2. 12.3. If h of x equals negative cosine 2x plus 10, describe fully in words the transformation from g to h. Okay, so firstly we see there's a negative sign there. And that'll be our a value, right? Which we said here is the amplitude, and that's calculated as maximum divided minimum over 2. But we have to multiply each y value by a. So what we did is we multiplied each y value of this function by negative 1. So what does that tell us? If we had, for instance, if we take 1 times by negative 1, it becomes negative 1. So all it does is it reflects in the x-axis. You can check that for any value you like. Let's say negative 5 becomes positive 5. That's just a reflection in the x-axis. So firstly, we have a reflection in the x-axis. Now, we've got this x plus 10 in brackets here. From what we said for that value, there's p and negative p. It's a horizontal shift. So it shifts to the right if it was a negative sign, or to the left if it was positive. Here we've got a positive, so we say it translated or shifts 10 units to the left. That is it, explained in words. Doesn't matter which order you do this, that'll still work. Now, for which values of x, where x is positive, will the derivative or gradient of f times the graph of g be positive? Now let's think about this for a little while. A gradient, we can look at a gradient to see if it's increasing or decreasing by reading it from left to right and seeing if from left to right if the graph increases or decreases, the y values for it. Okay, so that's what we're going to look at for f, and for g we'll just look where it is above or below the x-axis, see where it is positive or negative. And we know if we multiply two things together, let's say we multiply a and b together. For that to be positive, in order to be positive, we know that a and b must be negative, or they must both be positive. Okay, negative times a negative gives you positive, and a positive times a positive gives you a positive. So that's what we're going to look. We're going to look where is the derivative of f and the graph of g both positive or both negative. Okay, so since we know that a tangent graph is always increasing, we can see from left to right increases. It's an increasing function. So everywhere on the domain, f prime of x is positive. Right, so that's everything from negative 180 to 180. So now we need to find out where is g of x also positive. So where is g of x positive? Okay, where is this graph above the x-axis? Let's start looking at the left here. We've got g, so that's between negative 180 and 135, this spot here. Okay, so we can say between negative 180 and negative 135. Okay, so that's one area so long. It's just rough work to write down what we know. And then we see, again, from negative 45 to 45. Okay, from negative 45 to 45. And then where else? From 135 to 180. Okay, 135 to 280. And now in this case, your question is finished. This is your answer. Because this is where g of x is positive, and we know that f prime of x is positive everywhere. So this is where they intersect, where they both are positive. Or both negative, but we know that this is never negative. And that's it for question 12.